The definition of galvanic cell is electrochemical cell that makes use of chemical reactions to generate electrical energy. Also, galvanic cells are where two conductive metals, anode and cathode, are in contact and exposed to an electrolyte with a return current path.
Here is the difference between the galvanic cell and electrolytic cell. For galvanic cells, the cathode is the positive electrode and anode is the negative electrode. Next, the reaction that occurs is spontaneous and electric energy was generated by redox reactions. While for electrolytic cells, the anode is the positive electrode and cathode is the negative electrode. But the reaction that occurs was not spontaneous and electric energy changed to the chemical reaction with the help of an external source. There are four elements necessary for corrosion to occur in a galvanic cell, which are anode, where the electrode of galvanic reactions generates electrons. Next is the cathode, where the electrode receives electrons. For the electrolyte, the conductor through which current is carried. Lastly, the return current path is the metallic pathway connecting the anode to the cathode. All four elements are necessary for corrosion to occur. Removing any one of these elements will stop the current flow and galvanic corrosion will not occur. There are two primary types of galvanic cells that cause corrosion, the bimetallic couple and the concentration cell. A bimetallic couple is like a battery, consisting of two dissimilar metals immersed in an electrolyte solution. An electric current flow of electrons is generated when the two electrodes are connected by an external conductive path. A concentration cell consists of an anode and cathode of the same metal or alloy and a return current path. The electromotive force is provided by a difference in concentration of the surfaces through the external path.
For the figures shown, the steel and copper electrodes were immersed in an electrolyte representing a galvanic cell. The metal copper acts as cathode and iron, which is more reactive, acts as an anode in the galvanic cell. Current will flow from iron anode to copper cathode in the electrolyte. Meanwhile, the electricity flows from cathode to the anode through the metallic conductor. At anode, iron has a higher level of energy, so the corrosion will occur at anode. Besides that, at cathode, copper has a lower energy level, so no corrosion occurs at the cathode. Electrolyte is where water and dissolved salts conduct the flows of electricity from iron anode to copper cathode.
Galvanic corrosion is not required in many places, thus has to be prevented. There are various methods of preventing galvanic corrosion, which are avoid galvanic coupling, use of insulating material, paint, and avoid large cathode and small anode. Avoid galvanic coupling, where two metals that can undergo galvanic corrosion must not be placed together, otherwise one of the metals will corrode. Next, two different metals are kept together using insulating material in order to prevent the circuit formation and flow of electrons. Other than that, paint can help to create a barrier by covering the metal from corrosion. All of these are ways to prevent galvanic corrosion.